My number one requested video topic is microservices. I feel like microservices have been overcomplicated a little bit, so this video I'm just going to take you through a high-level overview of what microservices are from my own practical experience. This is not going to be a theoretical video. So firstly, what are microservices? Well, they're just small services. A microservice is the opposite architecture from a monolith. So a monolith is where your whole software product is wrapped up into one application. Don't get this confused with a monorepo. A monorepo can be used in a microservice architecture. In fact, that's a really good idea. A monolith, on the other hand, is the whole application. So you say yarn dev and up goes your product. Firstly, what are the problems with monoliths that we're trying to solve with microservices? So firstly, let's say you have a massive monolith and you get a new engineer on board. So for this engineer to be productive in this monolith, they have to learn a bunch of stuff. They can't just jump in and learn how this little service works. They firstly have to get this massive monolith running on their computer, which in itself can be a nightmare. So this is a real problem for the business when we have new engineers on board that are really slow to get started. So the second issue is scaling. Sure, you can scale a monolith horizontally, there's no problem with that, but each instance that you run this monolith on has to be bigger, in theory, than each instance that you would have to run a service in a microservice architecture on. So the other sorts of problems we're going to face are engineering sort of problems. Let's say you start out with a node. You're sort of limited in what you can do now. In a microservice architecture, you will just spin up another service that's written in a language that's more suited to this new task, such as Go or Rust. So don't get me wrong, microservices have their own problems and costs associated with them. A lot of these problems do have solutions, but a lot of these costs are just things that you're going to have to absorb because they're built into the nature of what microservices are. For example, let's say that you have a microservice architecture and you have 50 Node.js applications running in this architecture. So they release a new Node.js version, and over the course of, say, 6 months, there might be a security patch for 3 modules, and that's being very conservative. Well, all of a sudden, there's 50 versions of Node that you have to upgrade, you have to get all your tests running, you have to make sure your application runs perfectly. And on top of that, there's 150 modules that you have to upgrade. So each one of these modules that has a security version update. This gets really expensive, and there's just really not much you can do about it. You can use tools like Dependabot or Renovate to open the pull request for you. But at the end of the day, as a developer, it's your job to make sure that this stuff still works, even though you automatically merge in the dependency upgrade, for example. Let's dive in and have a look at what a mock microservice architecture might look like. So I'm going to build an e-commerce platform here, and we're going to start off inside of our VPC. And the fact that this is all running inside of a VPC is really advantageous. So the first service I'm going to have is going to be a user API. And a user API is responsible for registering users, logging in, and managing sessions, for example. So a user service, even though it is a microservice, is still going to be quite big. So you could offload things like the authentication into another service, and that's a decision that you're going to have to make as a developer or as an architect. We also have another microservice here, and this is going to be our products microservice. And our products microservice is going to be responsible for creating, updating, getting all the products and stuff like that. The next one we're going to have is going to be an orders microservice. And our orders microservice is going to be responsible for sending out invoices. It's going to be responsible for taking orders, calculating how much an order is worth, taking payment, and all that sort of stuff. The next service we might have might be a commission service. So in this platform, when you do an order, you might have a referral to that order. For example, Amazon, you can get a referral link, and the person that sent you that referral link is going to get a commission. Okay, so the first question is, does each one of these services have its own database, or do we have a shared database for all of our services, or can a couple of services, say orders and products, can they share a database? So the rule is, in a microservice architecture, each one of these services can be deployed independently. So each one of these services is going to have its own database. I'm just going to put the database here, and I'm going to say this is a DB. Okay, so our next question then is, how do these services communicate? So for example, let's say that our products service needed to record how many sales we had on a given product, so we can start making some recommendations off that. Well, our product service now needs to know about orders. So there's a couple of different ways we can communicate this stuff. First off, we can just use a plain old REST API, and this is going to work perfectly fine. We're going to be able to send a request to a different service. We're going to get a response code back. So if we get a 200 back, we know that this request was A-OK. Another way to communicate between the services is going to be gRPC. And this is going to be very fast for communicating internally between your services. And then another really common pattern for communicating between services in a microservice architecture is Kafka, or a message bus. So a message bus has several advantages. Firstly, it's quick. If you use Kafka, it can scale almost infinitely. And secondly, you can guarantee that a message was consumed. So it's going to stay on the queue until we know that it's been consumed. So let's put our Kafka service here. The potential downside for Kafka is that it's going to be asynchronous. So we're not going to send off a request and then get a response back like we would with a REST endpoint. We're going to publish a message. Kafka is going to say, yep, I've got that message. And then it could be consumed anytime after that. Usually it's going to be almost instantaneously, but we're not really going to know that. So if we depend on the message being consumed before we go on to the next action, we should look at something like REST or gRPC. So the next part of this microservice is, of course, the user interface. So let's put our user interface out here. This is going to sit outside of our VPC because our user is going to sit over here, and our user is going to be able to make requests to the user interface. So we have a few different options of what's going on here. So each service can have a public API, and it can also have a private API. So let's say we need to make a request from our commission service. In fact, we don't need to expose our commission service to the internet at all, which means we don't have to build in any sort of authentication logic. Well, we can make a request from here straight up to the user's private API. And this means that we can be a little bit more lax on security or authentication, to be more specific, because our private API here is not exposed to the internet. If we're getting a request here on the private API, we know that it's coming from one of our internal services. This is, of course, unless you get a hacker inside of your VPC, which if that happens, you're kind of screwed, to be honest. But there are things that we can do to sort of limit this blast radius. For example, we can host this application in different regions. So if a hacker gets into one region, then they don't affect the other regions. I'm not going to go too much into the security side of microservices. So let's come back to our user interface here. A user interface, of course, needs to communicate with this public API here. But what about products? On products, we also have a public API. And what about orders? We also have a public API here. So our UI now needs to communicate with all these different services. It's going to communicate with products. It's going to communicate with our orders. And this has a few different problems with it. One, we're going to get some weird waterfall requests here in our UI. This can make our UI really slow. Secondly, to develop this UI is going to be a technical challenge. We don't want developing UIs to be a technical challenge. We want developing UIs to be a user experience challenge, because that's how we're going to build the best product. And then thirdly, we're going to have to build authentication into each one of these microservices. This is going to be a massive problem. So let's add another layer in the middle here. So this layer, I'm going to call my BFF. And let's say this UI here is actually a web UI. This storefront has a couple of different UIs. It has a web and it has a mobile, for example. Well, I have this BFF layer here, and BFF is going to be your backend for front end. So this is a backend specifically designed for one front end. So all of a sudden now I can move these arrows to go to my BFF, and my BFF can now point to all these different services. And so my BFF is going to absorb a lot of the complexity of what it requires to communicate with all these services. A couple of technologies that are really great for building BFFs. One, you can use GraphQL. In fact, if you asked me 2 years ago, I would have suggested GraphQL. But now I would probably suggest something like TRPC, and I would build a monolith here for my UI and my BFF. In that I would have Next.js as my UI, and then I would have TRPC built into Next.js. So we also have a BFF here for my mobile server, and it's the same sort of scenario. Our mobile server only communicates with the BFF, and then the BFF for the mobile server can now communicate and absorb a lot of that complexity with these microservices. So you might be asking, why do we have two BFFs here? Why don't we just have one and then all the UIs share it? The purpose of a BFF is to build an API layer that is specifically designed for that UI, and in the hopes that making the UI will be much easier and much more secure, because the API that we're exposing to the world or to the internet is much thinner. So that is a really brief overview of microservices. If you have any questions, let me know in the comment section below, and I'll make some future follow-up videos to address those questions. Thank you for watching, and I'll see you in the next video.